x minus 1 squared. X plus 1 times x minus 1 squared. X plus 1, x minus 1 squared. Did I say blessing to you? Is that what I said? Did I say blessing? Is that what I said? Did I?
I mean, yes.
Did I? I don't know what I said. Okay. I normally don't say that. All right. Okay, you ready? Okay, over here, what do we have? On the left. 4x. Okay, so 4x is the left side. Equals. All right, canceling here is the x plus 1, right? Which means we still have an a, and then we have the x minus 1 squared still. Squared, right? Squared. And then we have plus, let's see, the x, oh wait, x minus 1 cancels with one of these, right? So what do we have there? X plus 1 times x minus 1. We have both of them still there, right? Plus, and now we have, let's see, here the x minus 1 squareds cancel, and we get c, and then x plus 1. All right. Yes?
Why did you have it so that it's x minus 1 and also x minus 1 squared, and not just the x minus 1 squared?
What? I'm not sure I understand. What? Say that?
For the fractions? I don't mean what you multiply, I mean just in the denominator.
Yeah.
Why do you have both x minus 1 and also x minus 1 squared?
That's the partial fraction decomposition technique. Is if you have a repeated linear factor, then what you're going to need is a constant over that linear factor, then a different constant over that linear factor squared, then another constant over that linear factor to the third power, until you get to this power. That's the technique. I can show you in the notes. But when I show you in the notes, it's not going to look, it's going to look terrible. There, it's that right there. So it's saying if you have, so P of x is the 4x, okay? So it's saying if you have 4x on top of some linear factor that's raised to the k power, first you're going to put a number, a, over that linear factor. Then a different number, now I'm using a and b, right, over that linear factor squared. And you keep doing that until you get to a final number, whatever it is, a, b, c, d, e, and then that linear factor to that power. So you see how it builds up? That's what you have to do. So that's the technique of partial fractions. All right, we good at this step? Okay, that's the master kind of equation we're going to work with. And we are going to run into a problem, all right? Let's see if we can get A. Let's see if we can get A. Let's go after A first. I'm erasing what I'm going to need in a minute, so you'll have to remind me that we got to go all the way back to this thing, right? So let's try and get A, right? So you look at A. Is there any factor in both of these that's not over in this one? X plus 1. So how can you make x plus 1 0? Negative 1. Let x be negative 1. Right? If we do that, the left side becomes negative 4. Right? Plugging negative 1 in right here. Equals, okay, be careful here. You're plugging in negative 1 for x. Negative 1 minus 1 is negative 2. Squared is 4 times a. Right? So you have 4a. And then what about the rest? Everything else goes away, doesn't it? Everything else goes away. So what's a? Negative 1. So far, so good, right? We've got one of the three. Now let's try and get b. So what you're doing is you're looking to see, is there a factor here and here that's not here? Do y'all see? This is the first time this has happened. There's no way for you to kill off the c and the a at the same time. Like, you can't pick a value of x to make this go away and this go away without making this go away, right? Like, to make this go away, you have to let x be 1. But if you make x 1, it's going to make this go away, right? And to make this go away, you have to let x be negative 1, but that also kills this as well, doesn't it? So do you see that this way that we've been using isn't going to work, right? It's not going to work. So we have to use an alternate method, right? But let's just keep in mind, we do know what A is, right? We do at least know what A is. We just don't know what B and C are. So now we have to shift our approach, all right? Now, historically, when I've taught this class, I've referred to this as the short method. The short method is us just trying to plug in values of x to make things work, all right? Now I'm going to do what I refer to as the long method because we have no other choice, all right? And that is, I'm going to multiply all this stuff out. Okay, just bear with me. It's going to be algebra now, right? I'm going to expand this. I'm going to do x minus 1 squared. I'm going to expand it. I'm going to multiply these two together. And then here I'm going to pass the c through. So let me just go one step at a time. So now I need to do my long method, long way. All right, we're doing the long way now. All right, 4x equals, all right, x squared minus 2x plus 1 plus b, and then x squared minus 1, and then plus c times x plus 1. The only thing I did here on this is I did x minus 1 squared. I did it in my head, right? X minus 1 times x minus 1, FOIL collected like terms. And then here I did x plus 1 times x minus 1. I FOILed that. That's actually going to turn out to be a difference of squares. Do y'all see that's just the algebra I did in that step? Yeah? Okay. Pass the a through now. Pass the b through. Pass the c through. Just do it. You'll see where we're going. Just wait. It's coming. 4x equals k. We have a in front of x squared minus, so that's a times x squared. Now when I do this a times negative 2x, watch how I write it. I put negative 2ax. So I put the a behind the 2. And then I have plus a. Okay, that's my a getting passed through to all three of those terms. Now my b gets passed through. Bx squared minus capital B, and then plus cx plus c. Is that all right? Now, the reason I did that is still not obvious to you yet. Let me continue, all right? What I'm going to do now is I'm going to kind of clump my powers together. So I'm going to say, all right, 4x equals, I'm going to put ax squared plus bx squared minus 2ax plus cx plus a minus b plus c. Let's see, did I get everything there? I had 2x squared terms, right? So I put those together, just side by side. I had a minus 2ax and a plus cx. I put those next to each other. And then anything that didn't have x, a minus b plus c, I put those there. That all right? Okay, now, this is the part that I think is weird because you're like, where are you going with this? What I'm going to do next is on the first two terms that have x squared, I'm going to factor an x squared out. Right? So imagine on those two, I pulled an x squared out. Wouldn't it look like this? If I pulled an x squared out of both of these? That's what I'm going to do, but I'm going to pull the x squared out, but then I'm going to reverse the order. So just let me write it. It's the same thing, right? Because multiplication doesn't matter what order you go in, right? I could distribute the x squared through like that. It's the same thing. And then on these two, see these both have an x? I'm going to pull the x out of these. Okay, I'm going to pull an x out of these and I'm going to pull it to the back instead of out front. Now, you have to pay attention. I'm going to put it in red because it's very important. I'm going to put plus here. Always, I'm going to put plus. And then in parentheses, I'm pulling the x out, right? I'm pulling the x out of both these, pulling it off to the back side. When I pull that x out, what's left here is the minus 2a and then a plus 1. Did y'all see that? Oh, no, plus c. Why did I do that? Plus c. Right? That's what I get when I pull this x off the back. Do y'all see why I put a plus here? This is a negative term. This is a positive term. I didn't want to put a minus there because then that would impact the c as well. So I put a plus there. Still good? Again, you're like, what the hell are you doing this for? The last thing I'm going to do is I'm going to put a plus again. And then what I'm going to do is, I don't need to put these in parentheses, but I'm going to. A minus b plus c.
So is this another like vector?
Nope. We're not going to factor. See, this is the step that's like, why did I do all this, right? Why did I do this? The reason I did it is because we have an equation, right? And what we need to do is any equation has to be balanced, right? On both sides, the left and right have to be balanced. So I'm going to come back over, I don't even know where to go anymore now because I feel like I need all of this, but I'm going to have to get rid of at least this. Let me get rid of at least this. So this equation must be balanced. I'm going to put it right here. 4x must equal, I'm going to leave a space here, a plus b x squared plus parentheses negative 2a plus c x, but then plus a minus b plus c. And I remember the first time I saw this as a student, this bothered me a little bit, but the more I thought about it, it kind of made sense. So if this side and this side of the equation have to be equal, this appears to be a quadratic, right? And that's what? Linear. So we need to see that in front of this is a 0x squared, and then plus we need to see that there's a number 0 there. And if I write that down, then do you agree that this coefficient right here on the x squared on this side must match the coefficient on that side? Like that must be what? 0, right? And then the number in front of x, right? The coefficient on x must match the coefficient on x here, 4. And finally, the number that's back here by itself without an x must match the number over here that doesn't have an x. Would you all agree? In order for those to be equal, that would have to be true, right? So what does that allow me to write now? A plus b must be what? A plus b must be 0. Let me write that down. A plus b equals 0. I won't leave a space. That's the first equation I have, right? Then what can you tell me about minus 2a plus c? That must equal 4, right? And then finally, a minus b plus c must be 0, right? And what you're looking at here in college algebra is what we refer to as a system of linear equations. We have 3 equations and 3 unknowns. So now we have to solve this. Yeah? But we have some good news. We know what A is, right? We know what A is. And that's actually going to save us a lot of work. Are there any questions on how I got this? The balancing of the equation like this. Y'all agree with this idea? Make sense to you? Okay, so I know that A is negative 1. So what can this equation become? Negative 1 plus B is 0. And what does that tell you? B is 1. So now I know what B is. And wait, A is no, A is negative 1, I think, right?
Yeah.
A is negative 1.
It's negative 1.
It's negative 1. So negative 1 there, add 1 to both sides. Yeah? Okay. So B is 1. And then, fortunately for us, I can do this one as well, right? Because negative 2 times A, right, that's negative 2 times A, right, plus C must be 4. And that tells me that C is what? 2. I've got A, B, and C. Right, because that's 2. These multiply to be 2, and then subtract 2 on both sides. So did I even need the third equation? I didn't need it. But you know what? Just for the sake of checking, let's see if it works. If I plug in A, negative 1, and then I plug in B, minus 1, and then add C, is it 0? Yes, it is. Okay, so it makes me feel better that I got the right answers here. All right. So if we had not known what A is, right? If we had not known what A is, do you all understand the amount of work that's still ahead of us here? Okay. So we got lucky. Pardon? We would use matrices to do that. we would use, well, you could still do it without matrices. You could do it just by, solving the system. Matrices just make things easier to look at, right? Okay, yes? We have A, B, and C. That was the goal. So now we come back over here and we write things down, all right? I erased the integral. Okay, I erased the integral, but y'all can, let me see if I can remember. I think it was integral x plus 1. Was it x plus 1? It was x plus 1. And then I just erased this. I have plus the 4x over that thing, right? But we just broke down that 4x to be a over, what's our a? Negative 1, a over, and I just erased it. It was right here, x plus 1. And then plus b was 1 over what? X minus 1. And then plus c was 2. And 2 is going to go on top of x minus 1 squared. Okay? Dx. Do y'all see what I've done? This right here is the partial fraction decomposition that we did, right? That was the breakdown. And can you handle each of these? We already said yes on this, right? Let's just go through these. I think this should go pretty clean. This should be 1/2 x squared plus x, right? This is my actual antiderivative. All right, this negative 1, I'm going to pull it out. Negative 1. Negative, I don't need the 1, do I? So if this negative came out here, what's the antiderivative of that? Natural log, absolute value, x plus 1, right? This one, again, ln, absolute value, x minus 1, right? All right, be careful. Pull that 2 out. I'm asking you right now to be careful. I pulled the 2 out. You're actually trying to find the antiderivative of this. And if you look back in your notes from last class, I said there are certain integrals we need to know how to do. This is one of them. We have a constant over not linear, but repeated linear. And when we have that by itself, we can do a basic u substitution. And if you squint your eyes, I said you want to get to the point where you're not having to write it down, but if you're not there, just remember this is like u is x minus 1, du is dx. This integral becomes 1 over u squared du. This is integral u to the negative 2 du. You use the power rule, you get u to the negative 1 plus c. So we already did all that a few classes ago, all right? So you all understand what I'm doing at least? Yes? So if I'm here on this one, my answer is going to be, there's going to be a negative, and then the 2 was still there, and then it will be x minus 1 to negative 1 plus c. Just don't put natural log, because it's not, right? It's not a natural log. There you go. Okay, we're halfway through class. We've done 2 problems, yes? Right?
Can you explain that part again?
What part?
The negative 2. Yeah.
The 2 comes out, so there's a 2 in front of this integral. This is the integral you're looking at,
Okay.
right? And then you just do a basic u substitution here. U is x minus 1. If you do that, then it becomes 1 over u squared. You bring the u up, u to the negative 2. You do your power rule. Do you understand it?
Yeah, I just didn't notice that you had play. I was still writing.
Okay. Just remember, when in the beginning of these notes, I say preliminary things we need to know how to do, right, in order to get through this section. You may need to go back and review those, because they're going to start popping up in different places now, right? All right, shall we look at another one? Now that's some enthusiasm. How about this one? Well, when you look at that, there is some good news when you look at it. What's the good news? No long division, right? No long division. I asked y'all to do this, right? To look at these, to try and factor. Yeah, so I hope you did that. x cubed plus 4x dx. All right, so no long division is necessary. So I go straight to the partial fractions. Let me try and factor that denominator. The factoring should be pretty clean, huh? There's only a what? So partial fraction decomposition. I have 2x cubed, wait, did I? That's a squared. 2x squared minus x plus 4 over the denominator, which I can pull out an x and it leaves me with x squared plus 4, right? Unfortunately, this is not a difference of squares, so it does not factor anymore, right? This does not factor anymore. So the question becomes, what do we have here, right? This is linear, agreed? That's linear? This is not linear. What is it? It's quadratic, right? And what, irreducible, right? I'm put IRR for irreducible. That just means it can't be factored, right? Obviously, if it could be factored, I'd want to factor it so that I had two distinct linear factors there. But I can't factor it. So now the question becomes, right, what's the technique? What's the technique? How do you deal with a quadratic? We know how to deal with linears. We know how to deal with a linear if it's repeated, but what if you have a quadratic? Well, here's the technique. First, let me deal with the linear. It's going to be exactly what I would expect, a over x, right? The way we deal with a quadratic that's irreducible is we're going to put the quadratic here, okay, like this. And on top, you don't put b. You don't put a constant, b. What you do is you put a generic linear expression on top. So you will put up here bx plus c. bx plus c. That is the method. That is how you deal with an irreducible quadratic when you're doing partial fraction decomposition. For every irreducible quadratic factor you have, you must put a generic linear expression on top of that. So do y'all notice if this is quadratic, this linear, that's 1 degree less than this, isn't it? X squared, x. Do y'all see we actually did the same thing here? What's the degree of x here? 1 up top. What's the degree of x up here? 0, because it's not there, right? This partial fraction is always just putting your factor on the bottom, and then you put a generic expression on top that's 1 degree less than what you have on the bottom. Now, the good news for us in this class is we are not going to go past quadratics. Like, we aren't going to have factors down here that are cubic. But if we did, we would put the cubic and then we would put a generic quadratic on top. And then that just extends, as far as you can think, right? But we'll stop at quadratics. All right, you ready? We're going to go. Let's do it. Partial fractions. So now I multiply both sides. I'm continuing here. I have 2x squared minus x plus 4 equals, I need more room. 2x squared minus x plus 4. So I multiply I'm multiplying the both sides by this, right? I'm doing it here, x times x squared plus 4. It cancels. And then x times x squared plus 4. And then x times x squared plus 4. Be careful here. Because this is 2 terms, I should actually throw that in parentheses if I'm going to do that like that. All right. So the left side, everything canceled except the numerator. And then here, I get my x's to go away. And you get a, still there, what else? X squared plus 4. Make sure you put that in parentheses, because that a has to multiply times that. And then on the other one, the x squared plus 4 cancels, and I'm left with the bx plus c, but then still times x. Questions? Normally, this is where we go try and find a, b, and c, right? And we usually try and do that short method, like, is there a way that we can, is there a way right now I can get a? Is there a factor that's over here that's not over there?
No.
What could I let x be? 0, right? I could let x be 0, kill this off, and I could go figure out what a is, couldn't I? Shall we? Let x be 0. Okay, what does that become? 4 equals, okay, what does this become? A times 0 plus 4, okay, 4, and then over here plus, this was gone, isn't it? That's 0, 0 times that, it's 0, so it's gone. And then you can tell me now A is 1, right? Yes. Can we get B or C? Well, you have to be able to kill this, right? To get B or C, you've got to be able to kill this off. But what's wrong? It's whatever you pick plus, square plus 4, you're never going to make that 0, are you? Unless you bring imaginary numbers in, which you're not allowed to, because this is not calculus of complex variables, this is calculus of real variables. So we're not allowed to even look over there, so we can't do it, so that means we need to now shift to the long way. And so for the long way, I distribute the A through. Fortunately for me, that A just goes right through. And then over here, the x goes through, bx squared plus cx, like that. That's just cleaning up the right side. I'm going to clump my things together again. Let's see, I've got ax squared, and I also have a bx squared. I have a cx, and the only thing that doesn't have an x is a 4a. Like that. That was just me moving things around. And then, let's see, here I can pull the x squared out. I get a plus b in front of x squared. Here I have a c in front of x, and here 4a is by itself. And now I get to do that thing again where I try and maintain the balance on both sides. So I know that a plus b must be what? 2. The number, the coefficient in front of x squared. I also know that this c must be what? -1 right there. Wow, I already know what c is, don't I? And then 4a must be 4, which means a is 1, which I already knew that, didn't I? But I'm going to write all that information down. I'm going to write down the equations, and then I'll solve them. So I have a plus b must be 2. I have that c must be -1, and I have that 4a must be 4. Do y'all see that we would have figured out that a is 1 had we not done the short way? We would have found that out? Okay, so this tells me a is 1. I already know that c is -1. And this, if a is 1, then that's 1 plus b is 2, which means b is 1. So I know what a, b, and c are. Y'all doing all right? Here comes the integral time, okay? I'll do it right here. So this integral becomes, when I do my partial fraction, it was a over x, right? A over x was the first piece. Yes? And then it was bx plus c. Bx plus c. So b is 1. So 1x minus 1. Do you know what I'm doing? I had this. Right, that's what we were doing with the partial fractions. Replacing a with 1, replacing b with 1, replacing c with -1. You all right? Okay. Can you handle this?
Yes.
Can you handle this? How? What is this here? This is a linear over irreducible quadratic, right? And so we should be thumbs up. We should be able to handle this now. right? I'm just saying we should be able to. Let's go do it, but we should be able to handle this. There are two ways to do the second one. Let me do the first one. Let me just get the first one over with. This is equal to natural log absolute value of x plus the integral x minus 1 over x squared plus 4 dx. And like I said, there's a couple of ways to do this, but I'm going to follow exactly what I told you in the notes. If you go back up to where I said, hey, these are the things that we should be able to do, right? All this stuff. These are the things that integrals we should be able to handle, right? And when I got down to this step, to this problem, it was right there. Example number 7. We have a linear expression on top, and we have a non-factorable, irreducible quadratic on the bottom. And this was that technique that I showed you that I like, that the tutors probably won't show you, right? That's what I'm going to do, all right, because that's what I showed you. So I'm going to work on this right now, and the technique for this is to let u be the denominator, and then take the derivative of that. The derivative of that is 2x dx. Do you have a 2x dx up top? No, you have x minus 1. We really want it to be what? 2x, right? Really want that up there to be 2x. So what I did is I multiplied the top and bottom by 2 on the outside. And then this becomes natural log absolute value of x plus 1/2. When I take that, so I'm leaving the 2 on the bottom on the outside. I bring the 2 up through the top, and I get 2x minus 1 over x squared plus 4 dx. I want it to be 2x. It's 2x minus 1, right? Any guess as to what I'm going to do now? Oh, wait, 2x minus 1. Oops, that's wrong. 2x minus what? 2. Sorry, that's my mistake. The 2 went through to both. I want it to be just 2x. Anyone see what I'm doing? Split it up. Split it into 2 integrals now. Split this into 2 integrals. Because you know that if you do this over that, you got it, right? And if you do this over that, you've got that as well, because that'll be a constant over that, and that should be like formula 17, formula 17. No? Okay. So natural log absolute value of x plus, let me split it into 2. Integral, let's see, 2x over x squared plus 4 dx plus 1/2 integral negative 2 over x squared plus 4 dx. That's me splitting this into 2 separate integrals, keeping the 1/2 in front of both of them. Equals natural log absolute value of x, okay, plus. Let's see. By design, what is this one? Well, u is on the bottom, right? And du is exactly on top. So this is the same as 1 over u du, isn't it?